Hi everyone, so in this video I'm going to talk about a new shorting algorithm, which is basically merge short. In the previous video I talked about the quick short algorithm. The merge short is also uses the concept of the recursion. So if you didn't know any basics of the recursion, you can go to the previous video and I explain a little bit of the recursion. And in my upcoming Java course I'll cover the recursion in depth with examples and the questions. For now, just prefer the previous video, or if you want, you can find any other recursion video and then come to it for more short, any other recursion video on other channels. I would prefer the Kunal's video on recursion. That would be great. So now let's talk about merge short, right? So merge short is also very efficient. Shorting algorithm is typically the same as the quick short, and it will also works on the constant space complexity. So we'll talk about the time extended space complexity later in this video, but for now let's explain the merge short, how it works, and what is the code of it. So let's get started with it. Okay, so let's start with the merge short. Okay, so merge short, as the name suggests, the name is giving you a hint. What is merge short? It's like merging something, right? Merging means if you have two lists, you are merge it together and you get a new list. That's actually merging. So what happens in the merge? If you don't know, if you didn't solve those questions, so what happens in the merge? In case of the merge, we have a two lists, two shorted list actually. Suppose we have a 3, 4, and 5. This is one shorted list, and suppose we have a 4 and 7. This is also a shorted list, right? So if we merge this two shorted list, we should get a new shorted list. That's the concept of merge actually. I'm not talking about merge short, but I'm talking about merging. Okay, this is the thing of merging, you can say. Merging two shorted list. What happens in the merging? So if you merge this two, what will become? It will become 3, 4, 4, and 7, right? So in case of the merging, if you have a two list, it will also give you the a shorted list. If you have two shorted list, if you after merging, it will also give you the a shorted list. If you also give a shorted list, okay. So first of all, in this lecture, we'll code the merging part and we'll code the merge short part. So let's understand the merge short first, and then we'll see how merging works, and then we'll see how merge short will work. Okay. So first of all, explain merge short. Okay, explain merge short. So if you have a list of elements, like any element can be 3, 4, 5, 1, and 2, can be any element. Now in case of the merge short, we took the middle element, took the middle element, took the middle element. Okay, basically we part it, we separate the merge short in two parts, like we divide the list in two parts. So what we'll do, we'll take this particular list and this particular list after dividing from the middle end, this two. Now what we'll do, it will be divided. Now we'll have 3, 4, it will have 5, 1, and 2, right? 5, 1, and 2, and then 3, 4. Now 3, 4 will be also divided into two parts. 3, 4 will be also divided into two parts. 3 like yeah, so 3. Here we also have 4. Okay, so in this case we suppose middle limit this, so now we can say it is okay. It's blue. Here we have 5. Color problem, I'll fix it, no worry. So 2. Now in this case it will also gets divided, and it will be like this, and it will be 1 and 2. So it is like separating one. It is basically the concept of divide and conquer. Okay, it is dividing it, then it will merge. Like, okay, dividing and merging, or divide and conquer. It will divide it and then it will solve it. Okay. So what happens? So what is the basic concept of merge short? Like we see how merging works, like, right? We like take two shorted list and we'll merge it to get a new short list. So what is the merging part? In case of the merging, suppose we have a single element in a list. Suppose we have a 3 or 2 or 1. So a single element is already sorted, right? Because you have to don't compare with any other thing. This single element, if you suppose that this single element, it is already sorted. 3 is already sorted by itself. 4 is already sorted by itself. 5 is already sorted. 1 is already sorted. 2 is already sorted. Right? So this is one element and it is should be sorted. Now what happens? Likewise, we use the merging. We took two sorted elements and we merge it to get a new sorted element. So what happens? Like merge sort, we took these two sorted elements, 3 and 4. 3 is sorted by itself, 4 is also sorted by itself. To these two elements, and we'll do a merge and we'll get a new list which is basically also sorted. So we get a new list which is basically also short. 3 and 4 is short. Now in this case, 1 and 2, we'll take these two elements, okay, and we'll merge it and we'll get a new shorted list. Can't see, this is the, we get a new shorted list, okay. And let's write here. So basically, okay, so we have a three like 3 4 here, 3 4. I have 3 4 here, okay, and this is 5 here and 1 2 here, right? So this one, this one now, okay, this one now, and this one now. It will go to the sum root one. So what it will do, now it will take this one, this one, and this one. This one will short it, this one will short it. So it will take it and it will merge it. So it will do 1 2 and 5. Okay, now we'll take this shorted list and this shorted list and merge it, and it will do, it will merge it and it will like print 1 2 3 4 and 5. See how it is sorted? It just sorted it by like dividing it and merging it. So that's how it works. Like it is that simple. It is that simple. So it's that simple. If it's of the time complexity, I hope you understand it, but it's not very complex, right? And when you're doing the like coding part, you will get more of it, but I think you can understand. Now what I'm saying, okay. Now let's talk about the time complexity. Okay, let's talk about the time complexity. The time is the same as the quick short, because here we're also using recursion, the divide and conquer technique. Time complexity here is also the same thing. We're dividing it, right? So uh, this takes, suppose this is the first step. Suppose it has one element. So suppose it has, okay, old page, okay, is it, okay. So it has one step. It is using one step. It is using two step, and just using 1 2 3 and 4, 4 steps. It is using please not 3, 1 2 steps, and it's dividing it by 2, divided by 2, yeah, 4 steps, and like what is 4 step, 5 2 1 2 3 4, yeah, 4 step you can say, and so on, and actually so on. So what it's doing, it is 1, or you can say 2 to the power 0, 2 to the power 1, and it is 2 to the power 2. Okay, now after that it will go to some nth, like nth element, and it will be to the power k. Some nth element, suppose like n number, suppose in the list we have n number of elements. Suppose in the list we have a n number of elements, so for n number of elements it will be to the power k. So okay, you can't see, that is the thing, and equal to the power k. And here also when you're merging it, it is also n equal to the power k, because in this case also it is the reversing it. It is like in this kind of structure. It's like in this kind of structure, new, and it will like this kind of structure. Okay, here it is, and from here also doing the same. So if this gets n equal to the power k, okay, I'm having it so bad. It's n equal to the power k. So this will also get n equal to the power k, right? That means two times. So if you get a condition n equal to the power k, uh, like n equal to n equal to the power k, and we take log in both sides, log of n equal to k, log of 2, it is the basic log like log formula. So after removing the constant parts, we'll take, or you can say k equal to log of 2 base 2, log of base 2, and okay, they will dividing it, and that's the basic formula. But I'll cover basic maths also in my upcoming courses, basic maths required for programming, and we'll also do a course on the maths required for the maths required for the machine learning and artificial intelligence. Okay, so for now it is k equal to log of n, right? So actually it is 2 log of n, because here we see in the both cases we get this kind of relation. So it is actually 2 log of n. So actually 2 log of n. Okay, and other case in the other case, in this case, not in this case, because we are not checking, not doing anything here, not we're just like dividing it. But in this case, we are generally taking two lists and we're shorting it. That means we're comparing the elements, right? That means if you're saying uh, like this has a two elements, that means it's two comparisons. If it has a two elements, that is two comparisons. If it has three elements, then three comparisons. Likewise, if it has n elements, then n comparisons. That means one comparison, two comparison, three comparison, and n comparison. At the last, we have n comparisons. That means for a comparison, if you say about the for comparison, okay, so for comparison, okay, for comparison, what you're doing, maybe one comparison, two comparison, three comparison, up to maybe n number of elements, that is within n comparisons. That means if you're plusing it, the basic formula, 1 plus n divided by 2, first element, last element divided by 2. Okay, so that is the case. Now the time complexity became, if you multiply this two, multiply this one and this one, if we multiply this two, what will become? Time complexity will become 1 plus n divided by 2 into 2 log of n. So 2 will be cancelled out, and it will become log of n plus n log of n. So this list, the dominating term, will be cancelled out for the time complexity, and it will become big of n log n. Okay, so the time complexity will be big of n log n. If you can't see, yeah, big of n log n in case of the Morse short. Now, this if the space complexity is same, we're not using any auxiliary spaces. That's why space complexity will be constant, and we speak of 1. So the space complexity will be big of 1. Okay, space complexity will be big of 1. So that's the nice time space complexity of the merge short, and that is the explanation of the merge short. I hope you understand it. That's the and that's the explanation of the merging. Now let's see how merging works actually. Let's see how merging works. The main part of the merge short is the merging. Dividing is not the main part, because it is like very less code. If you are going to the dividing part, we're using recursion basically. That's why. So like quick short and merge short both have iterative solution, but that is in that case also we are using stack. Ultimately we're using recursion only. So that is not profitable. This is the one you can use recursion, and this is very easy, and that is great, I can say. uh, so merging part, now what is the merging part? Okay, merging part. So if you have a two shorted list, suppose we have one shorted list 351, and we add the shorted list, suppose two, like, okay, so it should be shorted. Okay, it should be shorted. Like if you are shorting in ascending order, the both should be in ascending order. You're shorting in basically, if you're shorted list which one has the ascending order, that and the should have ascending order, and the shorted list we have which have a descending order, and the should have descending order. That means if you have the ascending like 3, uh, 4 and 5, so it should have a 1, suppose 1 and 2. Okay, so how merging works? So in merging, we'll take here I equal to 0, and here we'll take j equal to 0, and we'll take a new like array of the size, adding the both the uh, list. So this one list has a size 3, and this one list has a size 2. So then this array would be of the size 3 plus 2, which is basically 5. That means it is 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah. And for this array, we're taking another like iterative variable, which is basically k equal to 0, suppose. So what we'll check? We'll check if ith value, if ith value is less than 1, if this value is less than this value, that means if ARR of I is less than ARR of j. If it does, what will it do? Suppose this list like name is suppose shorted, suppose. Okay, shorted. Mm, so we will do shorted k, means we'll inserting k value since ARR of I is less than, and we are ascending order. That means shorted k will be ARR of I. That means we are putting it. This one is smaller, right? We're putting it ARR of 1. Putting it here 1. And change value will be incremented here. Uh, so in this case, in this case it's not. In this case, this condition. So if you inserting I, so I will be plus plus, and if this condition gets false, this is not true. In that case, we'll be adding shorted shorted k equal to ARR of j. In this case, we'll adding j. Okay, j, and j will in that case j will be plus plus, and at the last we'll plus plus k. So now we'll plus plus k. So what condition? Now 3 is 3 is greater than 1. That means this condition gets false. That means it will go to here. Shorted k equal to AR of j, and j will be plus plus. So j will now go from here to here. J equal to 1, and k will be also plus plus. So k will be now k equal to 1. K equal to 1. Now we'll again check this one with this one. Now again 2 is greater, 2 is smaller, 2 is smaller than this I, the element, so it's smaller. So 2 will be stored here, and j will be plus plus. Now j pointing to nothing, and k is also plus plus, k equal to 2. Now let's see, j's don't have anything. That means whatever we have like one list gets empty, like one list elements we have inserted, all the elements we have inserted. Now what left? We left with another list which is already sorted. So what we'll do, we'll don't make any comparison in this case. We'll just go and put all other elements, all the like other list all the elements in the sorted list. That means we'll do 3 here, 4 here, 5 here, and will be incremented likewise. So now see, both the this is sorted, both the list sorted, and we'll merge it to get another sorted list. Sorted. That's how the merging works actually. That's how the merging works. So if I write this condition, this sorting the sorting condition, this conditions in a good manner, let's write in the next page. It will be like this. It will be if ARR of I is less than ARR of j. That means lesser value is ARR of I. That means shorted of k will be equal to ARR of I, and I will be plus plus. Else, if it doesn't work out, if it doesn't work out, then we'll do shorted k is equal to ARR of J, and J will be plus plus. Okay, and at the last K will be plus plus of the shorted list, right? Kth index of the shorted list will be plus plus, or increment actually. That's the whole thing of the merging. So let's see first of all merging thing, but the code of the merging. Then I will code the merge short. Okay, then we'll code the merge short. So let's go to the applet, and we are the CodaGo shorting, and we are creating a label in the program with Java, and doing like merge short, merge short. We're creating the REPL here, and here we are. The link would be on the description below, the link of this applet. Okay, so now let's make an array and arr for shorting. Let's make two array, because first of all we are like doing the merging part, right? With coding for the merging part. Here of one equal to new end, it will be like suppose what it in 3 4 5, suppose, and 3 4 5 should be curly braces, not parentheses. Okay, so and in the second case will be ARR of 2 equal to new end, and it will be 1 comma 2. Okay, this is two short list and we have to merge it. Let's make a function merging static, uh, like where we have to we also have to return it, right? So end then the new shorted list merge, and we're taking two lists, ARR of 1, it's an array, and end ARR of 2. So we have to create a new shorted list with the size size of the addition of size of the ARR 1 plus size of the ARR 2. So you can say uh, int new size equal to ARR of 1 dot length plus ARR of 2 dot length, ARR 2 dot length, and we're doing int like shorted, and we are doing it equal to new end, and we are doing it as a new size. Okay, new size. So that is a new size. And so what is the case we are doing in the merging? We are doing int I equal to 0, like int, we're doing two iterative variable I equal to 0 and j equal to 0, and also k equal to 0. K is for the shorted list and I for the ARR 1, j for the ARR 2. So we are giving a loop here while I is less than ARR of 1 dot length, and 4 should be true, and j is ARR of 2 dot length. Okay, this is the basic condition, and now to do we have to check. Okay, so to check, how to check if, like if the error of this conditions, this this condition we have to write, this one, this one I have to write. So if error of 1, like if error of 1 of error of 1 of I is less than error of 2 j. Okay, error of 2 j, and it will be shorted k is equal to error of 1 I and I plus plus, and else shorted k ARR of 2 of j plus plus. So k plus plus, k plus plus. Now the remaining elements we have to store. So what is the condition for that? uh, Storing the, like putting the remaining elements elements in the sorted array. The remaining elements of the sorted array. That means while if any list has some element left, then we have to put it in the sorted array without any condition. That means we have to just do it like this. Sorted k is equal to error of 1 I, and I should be plus plus, and also k should be plus plus with indexing. K should be plus plus, okay. And like this, while for the error 2, we have to do while j is less than error of 2 dot length. So we'll do sorted k is equal to error of 2 j, and we'll do j plus plus and k plus plus. Now the two lists are merged, so to return it, basically we get a new list. So to return that new array, or you can say new sorted array, return sorted. That's the code of the merging. So let's do merge. I can say int sorted array, and we'll do merge uh, for error of 1, passing two arrays, and we're printing it, printing sorted array. Okay, sorted array. So we'll do 4 and I equal to 0, I is less than sorted dot length I plus plus, and we'll do okay. So sorted dot length, and we'll printing it system out dot print, and it will be sorted I. Let's see, let's run it. Okay, error, let's give it an error. Okay, let's go, let's see what is the error here. Merge. Yeah, that's the error is, I guess that's the error. Starting it, yeah, we need another braces for the class. Yeah. The after merging we will do 1 2 3 4 5, so you get the idea of the merging, right? Okay, so let's make a function of the merge sort, actually. So static end, right? Static end the array, and we do merge sort. And basically in the merge sort we are using merging, that's why we would need to create it before, like create the merge sort, like error of 1 and error of 1, like not error 1, this be error only. Okay, so error, and here we have merge sort. So what we are checking, if we get a single element, like if we get a single element, then we return, right? So if we get if error dot length is equal to 1, then we'll return it, we'll return the array, because it is already sorted, single element is already sorted. Okay, so it's done. Now we have to get the middle element. So int middle equal to error dot length divided by 2. That is the middle, right? Now we'll do the left part. Left array would be the left part after like after dividing it. Left part equal to merge sort dividing it. How we divide? With there is a function with arrays. There is a function in the arrays class. We have to first of all import the arrays class, basically arrays class in the Java util package. Import Java dot util dot arrays. Okay, we just import it. So it has a it has a function which is called copy of range, like this one, copy of range, and we are passing. That means it would make a copy, or it would make a copy of the given array from the start and end, from what start index to end index, and it will make a new array for like from that position. That means it will slice the array from the given start and end index. Like this is the for this start index should be 0 and end index should be m. Okay, for the left part, and for the right part, int right. Although I also do like basic, like the important uh, packages and the function of these packages in some other videos in the Java course, so don't worry for that. Just dot copy of range, and we're doing arr, and we're doing m, and here it is arr dot length. Okay, the last element. That means from the middle, like from the 0 to the middle element, and from middle to the last element, from the left and right, right? So that is the case, and now it merge it. We return the merge merge it, like merge it, merged list, left and right. Left and right. Okay, so that's the thing. We write merge short. It is recursive, so that means we're calling uh, the function within itself, and it is the termination condition, or it's a breaking condition of the recursive call. Otherwise, the recursive call will like go to infinity. It will never stop. So if you have a list, suppose if you have a list, like you're commenting it out, say for merging two elements, two arrays. Now I take a single array and arr new, and taking thing like 3 5 1 2 4, this, and what we're doing arr equal to, we're storing it here only, arr equal to merge short, if you're returning something, right, and it'll be arr, and we're printing it. Yeah, just run it. Yeah, 1 2 3 4 5. If you change it like 3 10 11, it will also work. Let's run it. Yeah, 1 2 3 3 4 5 10 11, so it's short. That's how merge will work. So let's try it here. Yeah, it'll be here. Printing the shorted array. Okay, here's the thing. For merging of two shorted elements is for like merging of two shorted arrays, and the basic thing, and this is the for dividing the array in two parts, for dividing the arrays in two parts. Okay, that's the whole thing of the mod short. I hope you understand the code. If you didn't understand the code, go to the explanation first and then come back in the code again. It'll take time if you're new to the programming. Okay, so because I have, you're using the concept of recursion, you're also using the concept of the packages, like the predefined functions in the package. So that is actually tedious if you're starting new here, starting with the programming new, but yeah, it is not that difficult if you try. So that is the video for must shot. If you like it, if you like it, then subscribe to my channel, share with your friends, share in social, with the hashtag learning with Ronak. And if you're learning in public, then like it'll be great if you're learning public. I mean, if you're learning public, then take a screenshot of this video, and you can like post it at your social media, uh, with the, of course with the hashtag learning with Ronak, and that'll be great. So that's for today. See you in the next video with the cyclic short, and that's for today. Okay, bye bye.